I talked about the fill surface tool and the boundary surface tool in an earlier video. I'll be talking about the differences between the lofted surface and the boundary surface, as well as the options that you have available with both. With both of these tools, we can work with open or closed geometry. In this case, I have two closed profiles that I'm working with. And typically when we're working with surfaces, we're going to use the boundary surface tool. It's generally a more accurate tool, has better options, and typically does a better job of creating the surfaces that we're going to want to work with. With either tool, the lofted or boundary, when we choose to close profiles, SOLIDWORKS is going to create a series of four-sided surfaces, or one four-sided surface if you have a closed single loop. In this case, we have a two-sided closed loop. If this sees in either the lofted surface tool or the boundary surface tool that you have a flat face, it'll create a planar surface at the bottom. And for our other section, it creates a four-sided boundary. One of the key differences, and one of the only reasons to use the lofted surface instead of the boundary surface, is the center line parameters. If we need something to stick specifically to a center line, the direction to in the boundary surface will allow this profile, or this entire surface, to follow this curve, but it won't make it the center line, whereas the loft keeps this line at the center of both of these surfaces. So if that's the most important dimension, or the more important dimension in your model, you may want to use the lofted surface tool. For most other options, the boundary surface will typically be a better option. And one of the main reasons to use the boundary surface over the lofted surface in more complex geometry is that the direction to is an exact match, just like that centerline parameter, whereas the guide curves in the lofted feature are simply guides. They're not exact fits. In this case, the geometry is probably going to be exactly the same, as it's a very simple geometry. But when it's a little bit more complex, or a lot more complex, SOLIDWORKS will use those curves as a guide and stick more closely to the profiles. So keep that in mind when working with either the lofted surface tool or the boundary surface tool. Once again, the boundary surface tool doesn't give any preference to direction 1 or direction 2, whereas the lofted surface gives preference to the profiles over the guide curves. In both of these tools, we can modify the connectors to change how the surfaces line up. In the lofted surface tool, by default, if I choose the show all connectors, usually you have at least 2 or 3 sets of connectors that you can drag around. You'll also notice with this tool that if you drag out a connector from a corner, it's going to create a new connector as opposed to just dragging this one. So this actually makes it a little bit harder to control the connectors within a loft. But still, typically it's not too difficult to make changes to this geometry. With the lofted feature, we also have the option to reset the connectors or undo an edit that we've done. And we have the same options in the boundary surface tool. I choose these out, typically if I show all connectors, or the default is show all connectors, we'll only have one connector to work with. And this will modify all of the surfaces present. But we can add as many connectors as we want, and one of the nice things about this in the boundary surface is that we don't have to worry about, if I drag this off this corner, that an extra connector is going to be created. You have full control over how to add the connectors and how to modify these. So I'd say this is a little bit more intuitive in the boundary surface tool. And once again, you can reset all those connectors or undo the connector edit. But as you can see, with modifying this with connectors, we can change the geometry quite a bit without having to add any extra splines or curves in the background. With both of these tools, as I stated earlier, you can create geometry between either open or closed profiles. If I'm using the boundary surface tool, I can create two surfaces, or I can create a surface between these two profiles, but I can't add in a closed profile, as you'll get an error that the feature's curves must all be closed or all be open. So once again, if I do this with a closed profile and choose this line, I'll get the same error. The feature curves must all be open or all be closed. Point is an exception that can be used as either an open profile or a closed profile. Just keep in mind when working with points what I had talked about in the previous video about degenerate surfaces. Typically, we don't want splines going all into one point. So for example, if I show this with the normal to profile option, we can see all of these curvature combs converge to this single point, which is generally not what we want. But you can use, like I said, a point as an open or closed profile. So as I stated in the earlier video, both the lofted surface and boundary surface can be used to create a boundary between multiple entities in a similar direction. With both of the loft and boundary surface tools, we have similar end conditions as well. We get this normal to profile, the default, the direction vector, and if we have faces present, we can do a curvature to face or a tangency to face as well. Just like the loft tool, you can use the selection manager in the boundary surface to select either open or closed loops. And if you have more than one entity in a single sketch, as I do here, you can select out these individually. Unlike the loft tool, we have an option under display for curvature combs in both directions. And this allows us to see the curvature as we're creating the surface, which is actually quite convenient. Within this display option, we can also change the mesh preview to see how each individual section is being created, or how all of these are lining up. And the curvature combs will be created based on the mesh density that we choose. One of my favorite options with the boundary surface tool is you can simply right click if your connectors are flipped and choose to flip the connectors. Within the boundary surface tool, these surfaces are also quite easy to trim just by dragging connectors. And if we hover over specific sketch points, once this turns black, it'll snap directly to a specific sketch or a specific point. So if, for example, I choose a normal to profile, I can see how my curvature progresses over this surface. At the normal area, this is going to be tangent to a line normal to the plane, as this is normal to profile. And on the other side, we see the curvature drop to 0, as on the other side we have a straight transition. Because we can drag the connectors in the boundary surface tool, it makes it easy to reuse multiple entities in several features. So I can drag out points on this line, and once I hover over this point and that connector turns black, it'll snap both sides of these lines to this side of the sketch, or this side of this spline. And so I can create multiple entities out of the same side profile sketch. Within the boundary surface and the lofted surface tool, we do have those tangency and curvature to face options. Just keep in mind that the curvature to face sometimes actually doesn't quite line up. Sometimes it's not able to produce curvature to face using this tool at every point along this line. So when you're using that option, it may be useful to create some face curves first, so we can analyze the curvature while we're creating these parts. So I'm going to create 5 face curves on each of these surfaces. And if I go to Show Curvature Combs, I can see the transition in the curvature. And it's nice to set these up in advance because it allows you to play around with the boundary surface tool and try to get everything to line up properly. So once again, if we look at that curvature to face, and set this to 4. We can see that the curvature doesn't quite match. Of course, at some points it may be hard to tell if the curvature matches in certain directions and not in others. As we can see, these combs run pretty much up and down, normal to the surface, whereas these combs do not. So these are things you have to play around with when working with this tool. If, for example, I created a 3D sketch, between these 2 points, I might be able to get a better match manually than I would have with the equal curvature option. And once again, it's sometimes a little bit difficult to analyze based on where these end up, as you sort of have to imagine where this spline's curvature would be in the same plane as this spline. But in general, this curvature matches up a little bit better than it did with the curvature to face option. So don't be afraid to create that curvature to face manually, or try to use a combination of both a direction to and a curvature to face option. One of the last things is that when analyzing these surfaces, we might want to use zebra stripes. The boundary surface tool has zebra stripes built in. So for example, if I wanted to create a boundary surface between the surface at the top here and these edges, one way of analyzing the result is to turn on the zebra stripes. And generally see how the surface works, or how the surface changes. As you can see though, with this option you don't get the stripes on the adjacent face. It's mainly for analyzing changes and inflections in the surface that you're creating. That is how you use the boundary surface tool as well as the lofted surface tool. And as I stated before, typically you'll be erring towards, or you should be erring towards the side of using the boundary surface tool, unless you are using that lofted surface with the center line parameters.